Wow, we've got 26 people now joining us. Okay. Good morning, Ahmedabad. How are you? Kem cho bada? Okay, for me, the only mode I can, listen to your feedback is the chatbot. So just, keep on writing there so that I can see the feedback and I can talk to you guys through that. Thanks, Manish. Good morning, Jigaboy. Yes, Manish, doing good. Vinay saying Majama. I hope everybody's at home, safe from all the chaos that we have. Yes, Kamlesh, I believe Corona should end soon. અમદાવાદની ગરમી આટલું બધું હેરાન કરે છે, રાઈટ? સાહિલભાઈ કહે છે જલસા છે, વાવ. આ ઓકે. છેલ્લા એક મહિનાથી આપણે બધા ઘરમાં છીએ, રાઈટ? એ પછી બી ઇફ આઈ કુડ સી સમબડી કોટિંગ જલસા છે, then it's really good. Good to see your, state of mind. Okay, guys, so let's start. Okay, can everybody see my new screen? The title of the presentation that we have. Yes, Rajan, you are right. IT field ને તો પણ holiday નથી મળતી. That's correct. Yeah, but it's good, right? So I believe IT is the only industry which is working at full scale, even after all these things going around, right? We are the only people who could work from our home. The only thing that we need is a laptop and an internet, right? Okay, good. So if everybody can see my screen, let's start. Okay, fine. So title for today's talk is all about how to evolve your applications to serverless, right? Uh, Ahmedabad is typically hub for web developers, mobile developers, and the stacks that we use normally are, PHP, LAMP stack. We have a good expertise on Java. We have good expertise on .NET within the Ahmedabad community, right? Now, how do we basically move our applications to the next gen architecture patterns. So that is how you could actually progress. How could you upgrade your existing, applications from monolith to serverless on, how could you basically move your applications to, achieve more scalability, achieve more, you know, uh, know more tolerance, like in terms of better fault tolerance systems, right? So that's where I think. Okay, now everybody can hear me well. Is there any lag? I got a feedback. Am I audible properly? Everybody can hear me well. These screens are working fine. Okay, great, great, fine. So I'm getting feedbacks that everything is going good. Okay, so guys, this is first time we are doing live stream in our community. So please bear with the glitches and things that go haywire. Okay, so over the time we want to kind of convert this into a model where everybody could basically participate and enjoy luxury of being at home and learning something new, right? Okay, let's continue. Okay, so I'm going in a presentation mode. So questions and things would be difficult to gauge, but let me just open up so that I can see what everybody is talking about. Okay, good, fine. So yeah, how to evolve applications to serverless. So a lot of you would know me. For those who don't, so my name is Ankit Seth. I'm founder of a company called DataViz. We've been working on serverless platforms, mainly focused on building voice bots on Alexa and other voice-enabled platforms. Over 2 years now. You could reach me on my Twitter handle. I'm very active there. Any questions or any suggestions or anything that you want to represent in the community, do reach out to us. Me and Nilesh bhai handles the Ahmedabad group. Taral bhai is also there. So uh, feel free to reach out to us if you want to speak, if you want to have further sessions. To let the community have the knowledge that you have. Okay, so let's start with this. We'll go with bit of serverless. We'll understand a few nuts and bolts around what is serverless, and then we'll move forward on how you can. uh, Yes, Kuldeep, you'll have time for questions after the session is ended. Okay, so please note down all the questions that you guys might have. Okay, I'm going to have this Q&A at the end of the session. So whatever questions that you guys see during the session, please note it down, and I'll take those questions one by one after the event, like after my presentation is done. Okay, so what is serverless, right? Let's start with this definition. So let's understand, how we reach to serverless, how we have seen the progress in form of computing. So, earlier we had servers in data centers where, all the different companies, MNCs used to have the data centers within their premise where they deploy the physical server. Time when the same enterprises moved from physical servers to virtual servers in the same data center, in the same physical data center, which means that you have seen trends like VMware Citrix, right, where they installed KVM on top of the existing infrastructure, and then you can on the same server you can create multiple virtual servers to deploy your applications and whatnot, right? The latest trend that we have seen in last 6-7 years is moving the same virtual servers into the cloud, right? It takes a lot of efforts and a lot of energy to maintain data centers, even if it's a virtual servers on premise, right? You need a good amount of working force to manage and maintain that data centers which is on premise, right? What happened in last 6-7 years is we have moved all that pain to the public cloud providers like AWS, Azure, or Google, right? Where we basically simply go to a portal and just click few clicks, and then we are good, right? We can get these servers like in a snap of a finger, right? That's what we have progressed towards, right? It has become very easy for us to get any sort of compute power that we need to run any kind of application. So each progressive step was better, right? So we traded capex for opex. So people who don't know capex and opex, let me just explain. Capex means capital expenditure, opex means operational expenditure. So for an example, earlier when people used to buy the servers, right, they basically have to pay everything upfront, then they get the deliveries, and they'll have to basically invest in those resources that they need. With virtual servers on the cloud, what has happened is basically we have traded with that fixed cost to an opex, right, where we are basically operating based on what we are using. So if you need this month a server which has 6 core, 8 core, or 16 cores of CPU with I don't know what RAM you need, right? You can simply start that server, pay for what you are using, and whenever your task is done, okay, you can simply go and close that server, right? And you are not supposed to pay anything other than the amount that you have used, right? So that's the trade-off that we have done. We don't need to invest everything upfront. We can trade our resources based on the usage that we have. We have better scalability, we have elastic resource, we have speed and agility, right? We see a traffic spiking up on our platform, we can directly go and increase the capacity of our servers, reduced maintenance. Like, it's been one of the best thing that has happened to IT world, right? Where basically the pain of managing servers and infrastructure has gone, to the people who knows how to manage it better, right? If you see people like Azure, Google, AWS, everybody has a fleet of people who could manage resources much better than a company who is managing a small data center, right? So each step that we have taken has led us to a better better outcome with respect to our way of developing and deploying application, right? So let's understand, there are still some limitations that we have seen, right? uh, Whether you are having virtual servers on premise or whether you are having on cloud, you still need to manage the infrastructure anyway, right? So you still need to administer the virtual server, you still need to manage the capacity and utilization. Okay, so all those aspects are still there. You still need to size the workloads, whether you need 4 gigs of RAM with 2 core CPUs or more. You basically have to size the workloads. You still need to manage fault tolerance, availability. You still, it's, and other thing is, it's still expensive to run intermittent jobs. So, for an example, even if you are trading or even if you are paying just for what you are using, the amount of running those resources is, if you compare, would be much more than the servers that you run on physical infrastructure or on your, if you buy your own server. If you see the cost factor, down the line for a year or 2 year, you would be, seeing that the cost would be much higher when you run something on virtual server. So these are some limitations which are there when you move from physical servers to virtual and from virtual to the virtual servers in the cloud, right? So what should we do? What is the next step that we should have, right? So that's what we are talking about here today. So it's all about how do you evolve, how do you take that next step on moving your applications from a monolith to serverless, right? What benefits it can bring, or what is the you know benefits of moving to serverless. So basically, serverless changes on how do you deliver, how do you deliver your application. So you would have dedicated time to innovation. So right now, if any developer joins in into the team, right, you basically have to walk him through the stack that you're using. You would have to walk him through on how you're building that stack. Then you'll have to tell him that how you're deploying that stack. These are the normal steps that we do, and at times we have to invest our developers time in understanding and managing you know the live infrastructure in terms of optimization and in terms of performance tuning and all, right? So with that, when you move to serverless, you are moving all that pain out, so you would have better time or dedicated time to innovating or to work on the functionalities that you want to develop, right? So you would be eliminating operational complexity, as I said, right? When you develop something on monolith, you have to take pain in managing the infrastructure, right? Versus when you move something on serverless, you basically don't have to indulge anything towards the operational aspects of any stack or any product that you are building. Okay, you would be able to increase developer productivity because see, as a developer, I only need to manage and maintain my code base. That's it. Rest all in underlying infrastructure, how to deploy and all that aspects is being taken care by the public cloud providers. That's one of the major advantage when you move things to serverless. Okay, And one of the prime aspect, and which is something very critical these days, is how, when you want to launch a new feature, into the market, right? So serverless also increase your speed and decrease your time to market. So something that you might be achieving in months time, you would be able to do that much faster when you use serverless. So let's understand, where should we use serverless? What are the key concepts or key use cases for using or implementing serverless as a architecture, right? So I think in Ahmedabad, we've been doing all these five aspects, right? Web applications. I think most of our outsourcing companies, the SIs that we have here in Ahmedabad, typically works on web application and mobile application, right? So you could create static websites, dynamic web applications. You could manage packages on Flask or Express or anything like that using serverless frameworks. You could create the complete backends for your websites or mobile apps. You be it mobile, be it IoT, be it web apps. You could basically create anything on serverless. I've been using serverless to do batch processing or to create analytics, using serverless products and serverless frameworks. Log processing or media, so live streaming like this, the stuff that we've been doing, right? If you have real-time data coming into your application, media and log processing is another use cases where you could use serverless as a frameworks. Something that we've been using in Dataviz for good amount of time is building chatbots and voice bots using serverless framework. See, chatbots and voice bots are typical use cases for event-driven compute. Okay, so serverless is completely an event-driven compute. Somebody asks for a service. Okay, your code gets deployed, and then you get a response. Okay, that's how this chatbot works. Okay, that's how the serverless works. So basically you have a system in place, a code in place, which serves for the traffic. Okay, when you have, okay, I see the screens moving. Okay, anyways, should be better now. Okay, so chatbots are a classic example. You keep on having a code available for anybody to use. For an example, I want to create a chatbot for analytics on corona, that somebody wants to query that. Okay, fine, what is the number of cases that we received yesterday in Ahmedabad, right? That's a typical query that we are looking at. And for that, you don't need to run a system 24 by 7, okay, and pay for that resources, right? So in a scenarios like this, basically if you use serverless, what's gonna happen is your code is available all the time. Okay, when a requester request for a service, this code gets up and running, serves that request, and then dissolves itself. Okay, that's the power of serverless. So chatbots, backends, web applications, these are the classic examples where you can and you should use serverless. So I'll take a break of 5 minutes, okay, between this before we move to the next part of this session. Can we get some questions on the chat box that we have? And I'll answer a couple of questions if it's there. I'll wait for a few seconds because there is a. Yes, can you still hear me? Can we add direct data on serverless RDS instance? So Kuldeep, your question is basically, can you add direct data onto serverless RDS? So see, uh, in okay, this uh, Kuldeep, let me answer your question at the end of this because I need to understand more on your question. Like you're talking about serverless and you're talking about RDS as well. I'll skip that and I'll take it at the end of the session. Is serverless architecture different for each cloud provider? See, uh, serverless as an architecture remains same in form of it's an event driven compute. So whether you're using Azure, whether you're using Google, or whether you're using AWS, principle remains same. So you need a service which can invoke the business logic. The in For an example, in AWS case it's Lambda, in Google it's Google function, in Azure it's Azure functions, right? So principally the invocation mechanism remains same. You can invoke it and then you have a business logic, and with that you can attach to different types of data sources, right? So principle or architecture remains same. The services may get changed from between cloud providers. So if you're doing something with AWS, the services that you use in AWS might not remain same when you move that to Azure or Google. Okay, next question is, so is there a web server like Apache behind role will be removed? Sorry, Hardik, okay, so you're saying that is there a web server like Apache which, okay, let me answer this. I'm not sure your question in much details, but see, you can use S3 buckets to deploy your static websites. Okay, so that can actually act as a web server. Now, when it comes to deploying dynamic web apps, so for an example, if I have a static website where I'm showcasing all the static contents, and with that I have a form through which I want to collect users' information. So for that, you need to use any kind of a JS framework, which is a client-side scripts that invokes an API call directly onto the Lambda backend. Okay, so what will happen is that call directly would go to the Lambda, and Lambda would serve that request. It would, for example, if you're storing some information from that form that you've collected information from the user, the Lambda would get invoked. It would process all the information. It would basically insert that data into database. That's how you can use, typical serverless architecture with web applications. I'm going to cover that going forward. Can we apply serverless for LAMP site which have mobile app too, and core size will be 200 GB and DB size will be 330 GB? Okay, so Bharat, really good question. See, understand there are certain limitations. Okay, you may not migrate something which is typically of this huge size, but there are ways to do that, and I'm going to cover that in going forward on basically how you can migrate from a monolith application to microservices. Why don't we take this question at the end of that, and you would have a lot of answers to that particular rest of the session. Can we say like Google App Engine deployment is serverless deployment? Okay, Malik, good question. It differs actually. So I don't have that slide in this slide deck, but see, there are layers of access that we get as a developer when we move away from physical machines to a serverless infrastructure. So the Google App Engine that we are talking about is basically a one level down from a container. Okay, so Google App Engine, it's not 100% serverless, but what happens in that case is Google App Engine basically allows you to manage certain aspects of that infrastructure. In serverless, you don't have any control on the infrastructure. That's the only difference. So, for an example, if you're using something with Google App Engine and you don't need to have dependency, or you don't need to have those features to manage the infrastructure. You can move actually to the serverless or Google functions, if you're using Google App Engine, which would allow you to move all those worries about underlying infrastructure. Can you please explain architecture of serverless, Kamlesh? That's gonna be available going forward in this session. So I'll go back to the I'll go back to the questions after a next section or next break that we take. I'll move to the slides again. So let's understand, a lot of good questions that we have seen. Bharat's question was also good. How you can migrate something which is built on LAMP and has a good, good size of code. So see, this is a typical monolith application. We have, for example, on the front end we use Nginx or Apache to load balance the queries that we get. Then we have HTML, CSS, the UI component, and then we'll have database at the back end to do relational stuff, or to if you're using NoSQL like Mongo or anything, to load all your information as a data source. Okay, then you have the business logic layer where basically you process all the data that you get from the user, and then do different operations and then store those information into database. You'll have your own cache, you'll have your own database to correlate and save all this information, right? That's the typical monolith applications that we have seen. So monolith versus microservices, this discussion, it's been there since quite some time now. All the application developers been talking about, what should we do? How do we migrate from monolith to microservices? One question that I've been getting, and I believe I'll get that at part of this session as well. That I have a monolith. Should I consider moving it to microservices, or should I consider that to moving into serverless? See, understand one thing: whether you are moving to microservices or serverless, the only difference is deploying it. Okay, one of the good question that Maulik had asked about Google App Engine, right? So you have monolith application, you have multiple services running on each and every this thing, each and every code block, right? You have different functions written for different services. You need to convert that, you need to distribute that into smaller functions. That's typically the definition of a microservice. Now, if we deploy that microservices onto containers or onto orchestration platforms like Kubernetes, right? We are again, running our services 24 by 7, but it's being managed by containers. It's being managed by container services like Kubernetes. Okay, concept is still same. We have defined microservices so that all our services has been separated into smaller chunks. But in this case also, you need to pay for the Kubernetes cluster or the virtual machines that you're running to run those Kubernetes clusters. Okay, you will have all the scalability, you will have all the fault tolerance, because Kubernetes would manage that infrastructure for you. Okay, but when you move to serverless, okay, again, concept is same. You still need to convert your whole monolith into smaller functions, smaller chunks, with in form of microservices. But in this case, you simply deploy your code and forget. Okay, all the underlying infrastructure, all the underlying scalability, fault tolerance, availability, everything will be managed by the public cloud provider. That's the difference between deploying something with serverless and deploying something with containers or orchestration platform that we use. Okay, so question very straightforward. That can I just migrate everything? Whatever I have in the existing applications directly to Lambda functions. Okay, you cannot. Different uh, nodes on your monolith application would have different ask when you want to transform that into microservices, or transfer that typically into a serverless infrastructure. Okay, so your web server could be replaced by an S3 bucket. Your app service could be replaced by a Lambda function, or you could use SNS for notification. You could use, if you're using queuing, you could use SQS, right? So there are different things that you could do within your application to migrate from monolith to serverless. Okay, there's no straightforward answer that I can typically take all my code and put it in Lambda. It will not work. It will not give you results that you need. So this is something. Okay, a huge shout out to two people. I've been fan of Yan Chui. He's one of the AWS serverless hero, and he's been doing good work on serverless. And I've been following a lot of resources that he's been sharing on how an enterprise should build serverless infrastructure, how people or a product manager should foresee the development of serverless as a pattern within their products, right? So all the learnings that I have, I've been implementing that into the products that I design, and I typically divide that into three segments: design, develop, and deploy. And it's from bottom to top. Okay, so first you need to design something. You need to then think of how do you want to develop it, and then you need to think on how do you need to deploy it. So that's the pyramid typically I follow when I design or develop something with serverless. Okay, 3Ds, as I said. So let's talk about the first thing, design. So see, typically it's not straightforward. Like, for example, we've been getting LAMP stack, right? Linux, Apache, MySQL, and sorry, Linux, Apache, MySQL, LAMP, and Postgres, right? I might be wrong, but so question is basically how do you map all your different services into serverless infrastructure, right? So you would have a web service, you would have app service, you would have something in form of visualization service. So, you'll have a data access layer, you have database. Yes, Gautam, thanks. PHP. Keep on forgetting that. So, so these are different components that we have. Now, question we need to answer within this is different aspects. So, for an example, uh, what do we have? What do we have in terms of requirements when it comes to compute? Okay, what kind of APIs we are using? Okay, do we have any API layer within our application? What is the storage requirements for our code base, the dependencies that we have, the modules that we use, the data that we manage through the system. For example, at times we have cache requirements as well, that certain information always remains on cache, right? So what do we have in that requirements, right? What aspects of security we need to manage within our application? What is the scale I'm looking at, right? How frequently or how quickly I'm looking at increasing or decreasing workloads and traffic onto my applications, and other aspects, like you know so typical what I do is I understand the product, I understand the KPIs. That's what I call. So, what are the key points that you need to address when you move from a monolith to a microservices, right? And then what I do is I try to map those key pointers to various services typically available in AWS. Okay, so for an example, for storage we have different options. Okay, we have DynamoDB, we have Aurora Serverless, we have RDS, we have Elasticsearch. Okay, so various options are available. Okay, we need to choose what fits well. Okay, and one thing I want to say that there's been a misconception among other product managers as well, that if I'm using serverless it has to be 100% serverless. It may not. Okay, if you are using a legacy system, for example LAMP stack, you've been MySQL for years now, right? How can you simply migrate a relational database to a non-relational database. It's going to be a groundbreaking change if you do that, right? So not necessarily you need to have 100% stack on serverless, but what you could do is you could basically manage the, for an example, in that case, you can manage the business layer of it. Okay, we did a project in which we manage, like, they were having all the things in RDS. Okay, we tell them fine, you use RDS, there's no problem in that. We created a separate data lake and we put all the data there, and we've been fetching records, we've been managing that data analytics using that particular data lake. We don't need to go to that database, right? So not necessarily you have all the components that you need when you decide or design a system which has to be a serverless. Okay, you have all the liberty to pick and choose in between, right? You need to understand that there are a couple of aspects, right? You need to understand how you can reduce your cost. That's one of the prime aspects. Second, how you can, reduce your maintenance cost, as in you need to keep people on board, you need to, keep things aligned to ensure that the infrastructure that you have deployed remains intact, right? Looking for, helps you to scale whenever there's a traffic, right? So it's not that, you need to transform that 100%, that okay fine, I am going to, scrap everything off and go 100% serverless. Do work and decide based on your requirements, that what fits well within the architecture of your application. Okay, so this is the typical architecture, a rough architecture that I see. This is the typical architecture of a web app. Okay, it could be mobile app as well. Okay, so a CloudFront is CDN for AWS. Okay, and with that we have Amazon S3. So, for example, I'm looking for www.abc.com. Okay, that browser would fetch the DNS records and it would point to the CDN, and then all the static resources that you need to deploy needs, like, can be accessed through Amazon S3. Then, as I said, we have a form on which customer fills up some information and hits send, right, to connect to us. That's the dynamic portion of the web app where we need to do some, operations. That's where API gateway comes in. API gateway would collect all those requests, and with that API gateway, we would connect a Lambda function, which would basically acts as an application layer or a business logic layer where you would write your code and, get the necessary operations done. And once that Lambda function has executed the work, okay, you would be storing that information in form of DynamoDB, right? So this is the typical architecture that we have in our uh, yeah, serverless architecture. So, you know what steps should we follow when we design a serverless, when we decide to, I want to design something with serverless, I have an existing product which I want to migrate to serverless. So to create a mind map, create a mind map of services. Okay, so what does that mean? So typically you have a monolith application in which, for example, uh, you would have multiple services. Let's talk about an e-commerce platform, right? You would have a service which would search the product, you would have a service which would get the product list, then you would have a service which would get the product details, you would have a service which would put that product into cart and then to check out and then do the payment, right? So this is the typical different services that you have within your e-commerce application. So when you are designing something, when you are planning to migrate something onto serverless, you need to create a mind map of different services that you can create. So, how do you distribute your existing application into smaller chunks? So create a whole map, you know, what services connects where, what is the dependency of one service to another. So before you go ahead, before you go to the development stage of this thing, you need to understand what are the different services that you have and what connection you have within that particular, services. Huh. So if you're running an existing product, okay, always start with low risk and non-business critical modules. This is one of the prime aspect. Okay, so if you are running something in production and one fine day you just decide that, yeah, let's migrate everything to serverless, don't do that. Okay, plan something basically which works, you know which has a non-criticality attached to it. For an example, a reporting module, right? Reporting modules, I think all the products that we usually, which brings analytics, which brings reporting information in form of different usage factors and whatnot, right? So this could be an ideal start point for you, where you could decide and design a system which could help you to move towards using serverless. Migrate incrementally to a newer stack with enough time for stability. Okay, so understand one thing. See, this is not just a, a simple development change. Okay, you are redesigning or restructuring an architecture. Okay, so this is the time where you need to give time for stabilizing the modules that you deploy. So for an example, I deployed a module of reporting. Okay, I need to make that module stable and then move to a next module. Okay, I cannot simply go back to back and deploy one module after another. Ideal strategy should be develop a module, deploy it, and give enough time to stable that particular module. Okay, services should have clear boundaries. So what I mean by services is, I'll go back to the same e-commerce module that we discussed, right? So in e-commerce, you have a service which would search the products. You would have a service which would fetch user information. Okay, so user information and searching of the services are two distinct services. Okay, you need to have clear cut boundaries on what is the role of each service. You need not to have something which is which is having an effect of multiple services. For an example, let's talk about users order data. Okay, so if you have a binding that in order for me to find users previous orders, I need to fetch the user information from the user service and then order information from order service. It's not a good architecture. Okay, your user order history service should have its own database and should have its own information stored within that service itself, so that you don't have dependency on other services. Idea is to reduce your effect of failure. So for example, if user service goes down, you are still having search service available, so that people can go out and do the searches, people can go out and do the orders, right? And development team can work on fixing that particular issue which is coming with respect to your your user service. Okay, and last and most important aspect is every service should have its own data to work upon. Okay, as I mentioned that when you have clear boundaries on your services, each service should have its own data store as well, so that whatever you are storing, okay, it also doesn't have any dependency on different services. Okay, there are various ways you could achieve that. Yeah, it's a topic altogether for a whole another session. But see, this was the design aspect. How you should design and what are the key points that you need to keep in mind. Let's talk about how to develop. Okay, one of the typical challenge that I see people. Yes, Rohit, asking something. So one of the typical challenge that I've seen is how to manage code base, right? When we are developing something with serverless, how to manage different tools that we might get which tools to use basically to develop something. There are uh, different strategies when it comes to managing code base. uh, I've seen people taking references on how people do at Twitter, or how people are managing code base at Netflix, typically how Facebook manages code base. See, understand one thing that I've learned is, see, all these companies, whoever we are referencing to, they have their own set of teams who manages the tech debt. Okay, so whatever code base the developers are creating, they have a dedicated team who manages that code base and manages that code base to be aligned in certain aspects. Versus if you're talking about somebody who doesn't have a dedicated team of developers in managing the code base, it's going to be very difficult, right? So what should you have? Should you have one service? Should you have one repo for one service? Or should you have one repo for all my services, right? These are two distinct options that we are seeing, right? My way or my suggestion in that is, always have one repo for all of your services. Okay, so typically there are two ways, right? You could deploy your whole product by creating multiple repositories. So for an example, same e-commerce model, if we take, search service would have one repo, then user would have another repo, then you know uh, user details would have another repo. It's a good architecture. And if you have 150 200 develop, developers working on a single product, this is something that could sustain, given a chance that you would have enough team members to help you manage that code base. Okay, but for a companies who don't have that much firepower, okay, it's always better to have a single repo for all your services, so that you can manage all the aspects of development and deployment through a single code base. Okay, that's something that you guys needs to understand. Okay, so second question is how to start development. What are the like how can I start to distribute my single function into multiple functions, right? Typically in a monolith function we have that if else loop, right, where if somebody says get users, then I'll fetch user information. If somebody says create user, I would create a new user. If somebody says delete user, I'm going to delete the user, right? Typically that's how we have created our monolith function. We have different functions with if else loop, distributing our overall functionalities. Versus the structure or the principle that you need to follow when you develop something with serverless is single purpose function. What does that mean? So we'll take the same example. So if you have a user endpoint, okay, if you are doing a get call, okay, it should be one function. If you are doing a post call, it should be another function. If you are doing a delete call for the same user, it should be a different function. Okay, API call is same. So API endpoint is same. From that API, we see three different endpoints, right? Get, post, and delete. And for each of that call, we would have separate functions created within our application, within our code. Okay. So why are we doing this? How can we do this? This is the example that I've taken from Yanchui's slide. You'll see his name as well, so all the credits to him. So see, when you use a monolith application, okay, for an example, you created something which is a single function which does get, delete, and post. Okay, now there are a couple of challenges in that. So it's a very straightforward example, but For example, you have an external dependencies in terms of modules for doing different functions. So for get, you have x limit x dependencies. For post call, you have y dependencies. So when you create Lambda functions, you need to be very cautious on what is the size of your code base, what is the size of your dependencies on Lambda functions. Why? Because typically uh, when you ask for a service, Lambda goes in, deploys its code, and then it starts executing that particular stuff, right? Now, in this case, what happens is the heavier the code gets, okay, more time it takes for Lambda function to respond. Okay, so it's always better to have something which is typically, you know, of a lesser or a smaller footprint and smaller dependencies. Okay, that's one aspect to it. Second aspect to that is easier to manage. For an example, if you know that you have a problem in get user call, okay, you would simply be fixing that bug and deploying that particular Lambda function only. You would not be deploying anything else. So that contains your responsibility on making sure the things are working fine. So given a chance, you have everything on the same monolith function. What's going to happen is, if you're fixing something on the get user call and the code that you've written got some bug or anything, you uh, introduce that bug within that application. Now what happens is, uh, the get calls, so anyways it's not working, but it would have effect on delete and post calls as well, right? Versus when you have single purpose function, it only limits to that get call. It will not have any effect on post calls or delete calls, right? That's something which is that's the reason behind having this single purpose Lambda function. Okay, so make sure that whenever you define services, within their services you need to define functions as well, that how you are going to distribute your single service into multiple functions. Don't expect a single service to have single function, because if you do that, you're again going back to the same monolithic functions mindset. Okay, what do we have next? The question is, which framework should I use, right? So I'll suggest you to go to the landscape of CNCF. Okay, you can go to landscape.cncf.io. Okay, that would give you, like, on the bottom right side, you would see list landscape as well. Okay, in which they are listing out various aspects like what frameworks to use, what are the different tools that are available with serverless, how do you enforce security when you do, what is the platform that we could use, what is the, if I want to do something of my own serverless, what should I use. So there are various aspects that is in this landscape that cloud native community has defined, and it's a good collection of resources that you could utilize if you are starting new on serverless, right? You would understand what frameworks are there using which you can do the development. One of the two famous frameworks that I've seen is serverless and AWS SAM. So if you want to build something which is a sort of cloud agnostic, it's not yes, Keyur, I know image is not clear. You would have that. That's why I given the link. You guys could go out and check that up. And anyways, I'll share this slides, post this session, so you would be able to see all those things in details. So if you want to make your applications a sort of cloud agnostic, serverless is a platform where you should give it a try, because it would allow you to manage your application across clouds. So it's not just limited to AWS, but it would allow you to develop and deploy something on Azure or Google as well. So Let's understand, what steps should we follow when we do the development. Okay. First and foremost, this is something that everybody needs to understand. Don't try new things in form of languages with serverless. Stick to the languages you have in-house expertise upon. Okay, serverless. Like for example, if I talk about Lambda, they support Go, they support Python, Node, Net. Okay, they support even PHP, Laravel. They have their own. They basically have done a tie-up with AWS, and they have come up with their own custom runtime to run PHP-based application on AWS serverless framework as well. Okay, equip the developers with the microservices mindset. This is very important. Okay, why? Because see, as a developer, we've been developing something which is completely centric to a file. Okay, that's typical my experience, right? When I used to develop years and years earlier, we always talk to other developers in form of files. That if you're talking about users, then there would be a single PHP or a single Java file in which all the user related information is there. You have different functions developed within that same application, within the same file, right? So you need to equip your developers with this microservices mindset. You need to understand. You need to make them, clear that when we are designing, when we are developing something specifically with serverless, everything is distributed. If you are doing get user call, it is one lambda function. If you are doing post user call, it's a second lambda function. You cannot have single lambda function which we do multiple operations. Single operations, single lambda functions, or single operations, single microservices. Okay, so kind of you need to guide your developers in that aspect. Standardize the tools that you would be using for development. Yes, this is very much essential. With serverless, one of the main challenge is developing and then testing it locally. Okay, you don't have any interface to test things locally. You could do local invoke and you could do local API calls, but you cannot do end-to-end integration test locally. Okay, that's why the tools that you are going to use to develop your application, it has to be standardized organization. Okay, so for an example, if I'm using Docker containers with Visual Studio Code, for an example, then it has to be standardized across organization that everybody needs to follow this tool chain. Why? Because of different tools would have different setups on running this serverless infrastructure locally or testing it from AWS to your local infrastructure. That's why the tool chain that you select, it has to be standardized across your organization. Yes, very important. Stick to one framework and develop your expertise in it. Okay. So you would be tempted to try out different frameworks at times. So somebody says that serverless is good, somebody says the AWS SAM is good, somebody says Apex is good. So understand one thing, different people or different organization would have different need. Okay, so it doesn't matter if one framework works for one company, it has to work for you. It is not like that. You need to identify what works best for you. Okay, so if you're developing something with Node.js, the frameworks would have certain advantages. If you are developing something with Python, there could be other set of advantages that I get if I select another framework. Okay, so identify the framework which works best for you, and then work out things around that. Keep the function simple and single purposed. The same thing that we discussed, right? That function has to be very simple, right? It needs to do a one set of actions, one set of operation, and that's it, nothing else. And keep it single purposed so that it doesn't do multiple things within the same lambda function. Okay. Yes, very important question. How to deploy? Okay, this is again something that I've taken from Yanchoi's presentation. That how should you align your teams when you are designing and deciding to develop something with serverless? So You would have multiple engineers who would work in teams. Those teams needs to be assigned certain services. Okay, those teams needs to have their own services. So, for example, same thing. We talk about user as a service. In user, you would have multiple operations, right? So, a set of microservices needs to be assigned to team one, and then you would have team two who takes care of search services and whatnot, right? So you would have design teams which is working on different services, and that services would consist of one or more functions. Understand that, right? So user is one microservice, but in user you would have different lambda functions, one to make get call, one to make post call, one to make delete call, right? So that's how the differentiation has to happen when you are designing and developing with microservices. But you know, how do we? So I've done designing, I've done development. What should I do to close this channel, right? What should I do to make sure that we have end-to-end visibility? So next aspect to that is, once things are ready, how do you deploy that, right? What kind of a CI framework that you need to use? How do you monitor the infrastructure? Because see, it's not a monolith application where you go or set up a tool which would monitor CPU performance, hard disk space, and whatnot. Text for serverless. Why? Because you don't have on those parameters when you are designing and deploying something with serverless. You need to consider scenarios where you know how many of your lambda functions are being timed out, how many your lambda functions are being errored out, how many, like, what is the average execution time that a lambda function is taking. You could use open tracing platforms to track that. For example, if I'm making uh, SQL queries within my application, so how much time it is taking to establish the connection, how much time it is connecting to execute that query, how much time it is taking to respond back to the user. So different ways, different mindset has to be established to monitor and deploy the application. So there are various deployment frameworks that you could use: AWS SAM, Serverless, AWS CDK, Cloud Development Kit, Terraform, Zappa, Chalice. These are some of the frameworks that I have kind of used and seen that it benefits the you know developing and deploying applications with serverless. Now the question is, why should we use frameworks? See, uh, frameworks is nothing but a standard guidelines which would help you to move things faster. Okay, creating a lambda function physically on AWS console is easy, but if you do the same thing using AWS SAM or using serverless as a framework, it is much easier than that as well. You could manage your whole deployment options from your IDE using this frameworks. That's the power of using deployment frameworks. Okay, CI/CD tools. One of the prime aspect, right, that you need to consider when you decide to move to serverless. Why? So think of it this way: when you had a monolith application, you had a whole deployment strategy where your code gets. So if you're using Java, your jar gets built and then it gets deployed, and then you restart the server, and that's the process that you've been following, right? Now, same single jar file has been distributed to maybe what, 80, 100, 150, or 200 different functions. Now, how do you deploy that? That's where you need to take support from CI/CD tools. I've been fan of GitLab CI/CD. I've been using it for last 2 years now. I've been using internally to deploy my websites, to blogs, and whatever. Right. So, see, You need to identify what works best for you. Okay, you need to identify which CI/CD tools works best, in terms of expertise, in terms of requirements that you have. See, these two things go hand in hand: deployment frameworks and CI tools. Why? Ideally, you would be executing the same commands that you are doing executing locally from your ID through a CI/CD tool, which basically would orchestrate and deploy all those different, application stacks that you need onto your production or onto your development infrastructure, right? So CI/CD tools are very, very much important with respect to deploying something with serverless infrastructure. You could use anything. You could use code build. You could use GitLab CI. You could use Jenkins. You could use GitHub Actions. Various options are available. Okay, monitors. As I said, conventional monitoring tools doesn't work well with serverless applications. Why? Because the way we are monitoring the monolith application gets completely changed, move from monolith to microservices aspects. You basically want to see how's the error response, how's the different, you know, KPIs with respect to your stack. What is the response time? How many times we are getting timed out? Are there any errors being seen on the logs of your Lambda functions? These are some of the things that are there, and that's where you need to try out new edge monitoring tools like Thundra, Hexagon, Lumigo. So these are the frameworks that has helped me to bring visibility into the stacks that I've been running. Okay. Uh, One of the main reason behind using this is, see, monolith application is completely running on servers, right? So you would be using, various applications to track your application performances. Those tools are still valid. Okay, you could use open tracing platforms to trace the various aspects of application within the serverless frameworks as well. Okay, so it's nothing new, but the usual aspect that you do, right? Servers went down. What do? You have an alarm set and you try to manage that out. But in serverless, you don't have any servers to manage, right? What kind of alerts that I should set? What kind of monitoring I need to do? So some of the things that I've been doing within my company is I keep on tracking that how many invocations day in day out I'm getting, how many concurrent requests that I'm getting, what is the average time my each Lambda function is taking, uh, you know, what is the cost that I'm looking at with respect to the executions that are happening with respect to Lambda functions. Okay, but keep one thing in mind. If you have a service which is pretty much required to run 24 by 7, okay, and you are thinking that if it's not going to give you advantage in terms of costing, serverless is not an ideal strategy for you to consider. Okay, so typical example that I give to other, like, a lot of my customers, right? Costing is one of the main aspects, when you move to serverless, other than manageability, right? That when you run something on a physical or on a virtual server in cloud, for example, a development grade stack would cost you around what, 50 odd dollars a month. If you are running something similar to production grade, where you have multiple servers, multiple database servers running, you are costing around what, 320, $330. It's a generic example that I've taken for a web application. Versus when you do something with respect to serverless, the whole costing gets changed. Instead of number of servers to number of users per month. Okay, everything is event driven, right? So for an example, the cost that I have derived here, it's like, if one user comes to my website, okay, this is the cost that I'm looking at per month. Okay, so this is the cost that I have for each customer that comes to my website. You can increase that with number of users that you are expecting, and you could see the cost factors. The main advantage here is basically you are not doing any ideal costing. So when you are developing an application and putting into production, you need to make sure that it is 24 by 7 available, which means you are being billed for that particular application 24 by 7. But if I move to serverless, I'm going to pay for those resources when somebody asks for it. So whether it's like if I get good amount of traffic on my website, yes, I would be happy to pay for it, right? If I'm not getting traffic on my website, okay, fine, that's no problem. I'm not being charged for those resources, right? That's the main advantage when we use serverless. Okay, guys. So this is typically all I had for today. A standard strategy: design, develop, and deploy for moving your applications from monolith to microservices. So I'm gonna go back to the questions now. Okay, so shoot your questions. I'll first take question from Bharat. What he had asked, that can we apply, serverless on a lamp site which has 200 GB of code and DB size of 30 GB. So Bharat, first, as I said, you need to think for a way on how you can distribute your existing code base into smaller service. Okay, that's one aspect. It doesn't matter whether you're using code size of 200 GB. I'm not sure whether it is including dependencies and whatnot, but if you divide that into smaller services, yes, you would be able to run that up. Okay, DB size of 30 GB. If you're using structured database, you could still continue using that. Okay, and with that, at least your application layer, your business logic layer gets transferred into serverless. So that would give you a lot of uh, benefits when you move from server to serverless. And you could reach out to me. I would love to speak to you further on this, because this is something interesting and exciting. So guys, can I have some more questions? Did I skip any questions which I said earlier? Let me check. Okay, can we add? There was a question from Kuldeep. Can we add direct data on serverless RDS instance? So, see, data is coming through various interfaces, right? So, what I understood by your question is you have a database, you don't want to use any API layer, you just want to directly dump your data from your application, from your interface directly into the database. Yes, you can do that. You could use Lambda function to connect directly from your from whatever interface you have to Lambda, and that Lambda function would execute queries directly onto the code to save that information into database. Guys, shoot your questions. We'll have 10 more minutes. Yes, Kuldeep. You would like after our call, see, in the description, you would be able to see the slides information as well, and this video would also be available on our channel, so you could watch that at any point in time. Any more questions, guys? It's required MySQL Server. See, uh, in serverless, there are other options which you could use when it comes to serverless database, but you could run this with anything. So if you have a MySQL server running, you could use that as well. There's no problem. Any other questions, guys? Okay, I get a question from Sandeep. Does Lambda runtime have persistent layer? That is, if I'm doing some file processing and I need to store file temporary, would it be possible? So, Sandeep, to answer your questions, Lambda by default is completely stateless machine. Okay, so it's not going to save anything. Okay, just 1 second. Dishi and Archana, I've got questions in front of me, so it's okay. I have my own setup, so you don't need to send questions separately. So no need to do double time there. So yeah, coming back to Sandeep's question, uh, what I used to do is whenever I need to store something with respect to files, okay, which needs to be persistent across Lambda functions. So for an example, uh, I'm getting some files from the front end and I need to process that, and then I have another Lambda function, I have another service which would pick that file up and do further processing. What I used to do is I used to use S3 for that. So what you can do is you can execute a Lambda function, save that processed file into S3, and give a reference in form of database or inputs to another Lambda function which would take that forward. Okay, KU's question. How to separate dev, test, and production? Really good question. Okay, so that's something that I've been using CI tools to execute with. So I've set up a standard nomenclature for my applications that when I execute CI pipeline, okay, I keep a variable as environment. So if I am deploying something for dev, I'll set that environment variable as dev. So what's going to happen is all my stack, all my functions which are being deployed would have a prefix of dev. So that's how I'm distributing. So dev, production, and QA would have different application stack divided based on this nomenclature. That's how I'm differentiating. Other than that, another strategy that I've used is I'm using different regions. So my dev remains in US East 1, my QA is in US West 2, and for production, I'm using a separate AWS account. So that's how I'm managing, different this environments uh, you know, within my company. Okay, I see a question from Anvit. As serverless is event driven, so what kind of a security measure should we take from client side code to access our resources? Okay, so there are various aspects that you can implement. Okay, so for an example, between CloudFront and S3 bucket, so I'm having CloudFront distribution, which is the front end of my website, and I want to secure my S3 bucket that nobody else other than my CloudFront distribution should access my S3 bucket. So we could actually, restrict the origin only from, CloudFront distribution. So you can update the S3 bucket policy to have access only from CloudFront. That's one thing to secure your static code. Now, when it comes to dynamic code, when APIs that we are running, we want to secure that. You could actually there are multiple ways you could do that. You could use an API key based authentication, or you could actually do a custom authorizer function. What that will do is basically, when somebody comes from the website, it gets an authenticated code, okay, and when that particular person submits something to API gateway, that authorizer function would be invoked first, which would give the token back, and that would be sent to call the actual function to serve that particular request. So that way you're not exposing your direct code, your direct APIs to the end user. Is there any downtime involved when we do release over the time? Sandeep, I've been using for last 1.5 years now. See, when it comes to managing serverless infrastructure, I haven't encountered any downtime as such. Okay, there would be there would be downtime maintenance windows and everything which AWS would be managing on their side, but nothing that is visible to us in form of our application availability. Okay, I've been running a system in one of the restaurants here in Jaipur for last 6 months now. No downtime whatsoever. I've never got a complaint from them saying that, hey, the service is not available or your application is down. Any other questions, guys? Okay, I see there's a good amount of lag coming in. Okay, guys, I believe we are at the end of our road. Before we, okay, I see one more question from KU. When to suggest serverless and when to suggest container-based setup? Really good question. Okay, it's a tricky one. See, understand one thing. There is a very thin line between containers and serverless. Okay, when you want to have a service which is you know limited to events. Okay, for an example, if I have a service, for example, I'm running a website which is having a single form which collects different information, it's an ideal way or ideal thing to deploy it on serverless. But if the same website is being utilized by a million subscribers a month, okay, you should consider moving from serverless to containers. Why? Because when you have such load onto your website, okay, that's gonna give you better cost uh, over the time when you move away from serverless. See, serverless is a higher priced compute resource than a container or a virtual server. Okay, because AWS or any public cloud provider manages the complete runtime, complete infrastructure within. So they basically ask for a better price since they are managing everything, right? So what I usually do is I look at the monitoring factors like what is the load that we are expecting, how many people are expected to come onto the website, and what's gonna be the cost if I run that whole system onto serverless versus if I run that system completely onto containers or Kubernetes. If it gives you 30-40% cost advantage, then it's a right strategy to move towards serverless. Okay, I see one more questions from Kuldeep. Okay, I request to. Okay. Yes, Kuldeep, that's correct. This is the first session. That's why I haven't done any live coding yet. But you would be seeing sessions where we are going to do certain live coding sessions together. Okay. Yes, I see another question with Darshan. How can we integrate AWS SQS service to pull files from S3 buckets and execute business logic with Lambda? Ooh, okay. So you have a requirement of. Uh, okay, so you, if I understood correctly, you would get uh, file information from SQS. No, I think your question is more on. Okay, okay. Fine. So you could use SQS as a invocation to invoke the Lambda function, and that SQS should give you the file key, okay, which is there on the S3. You could use Boto library within AWS Lambda to pull that file from S3 bucket and process the business logic that you want to run within the Lambda function. I think that should do it. Any other questions, guys? Okay, I guess we'll conclude the session here. Oh man, I've got another question. Okay, if I have an application which requires OS level access, application is using some components which uses GPU or something similar. No. So understand one thing. Lambda completely runs within a container. Okay. If you want to access GPUs within the containers, it itself is very difficult. Okay, so if you have things which needs OS specific access, OS specific things, I would request you to do it in containers or on a physical machines. Otherwise, you will have very limited access. You know on the Lambda side. Uh, like it has limitations for storing and managing files as well, so not an ideal strategy. Okay guys, I think we'll conclude the session here, not taking any more questions. We are about to end the times as well. Okay, so thanks a lot everybody. It's my and rather a community's first attempt to do a live session, and it's good to see at least 30 people were there when we started the session. So it's good to see these numbers when we are doing a virtual meetup. And thanks a lot for joining us. And hopefully you'll see good sessions coming down the road as well. And don't forget to subscribe Serverless Ahmedabad meetup group. Uh, we have created a separate group typically for having sessions on serverless, although you will get the same information on our AWS Ahmedabad group as well. Okay, so see you guys next time. Thanks a lot.